Question 12 is asking us to solve the system of equations. And so there's a couple different ways you can go about this. One of them is by graphing out these equations and finding the point where these lines intersect, and the x and y values of that point are going to be the solutions for x and y for the system of equations. But a possible problem that can come up with that way is that if your lines intersect in kind of a weird way, it can be kind of hard to see what your x and y values are. So the way I like to do it is algebraically, and that kind of makes it easier if your x and y values are kind of weird numbers. So let's do it that way. I'm going to start by calling these equations equation 1 and equation 2, and that's just going to make things a little bit more simple when I'm referring to them later on. So let's start with equation 1. I'm just going to rewrite it here. It's 6x plus 2y equals 0. And so I want to start by solving for one of my variables in this equation. And I picked this one because I kind of have some nicer numbers here that's going to give me a really simple equation when I solve. So I'm going to solve for y. And so what I'm going to do is subtract 6x on both sides of my equation. And this is going to give me 2y equals negative 6x. Dividing by 2 gives me y equals negative 3x. You can see that kind of worked out nicely, and as you do these, you'll get better at seeing which ones are easier to solve, which variables are easier to solve for, and will give you kind of a nice simple answer. So now we have an expression for y in terms of x. What I want to do is go to my equation 2, which I'm going to rewrite here, 7x plus 3y equals 2. And what I want to do is substitute my expression for y, my expression for y in terms of x in for y in this equation. So that's going to look like this. 7x plus 3, we've said that y is equal to negative 3x equals 2. And so now I have only the variable x in this equation, and so I can solve for x. So let's do that. I have 7x, 3 times negative 3 is going to be negative 9x equals 2. So I have 7x plus a negative 9x, and that's going to give me negative 2x equals 2. Dividing by negative 2 on both sides gives me x is equal to negative 1. Okay, so we have an answer for x, and what we can do with this is plug in this value for x into either one of our equations and solve for y, and either one of them can work, but I'm going to go back to equation 1 because I've already set up a nice equation for y there. So taking my value for x as negative 1, this gives me y equals negative 3 times negative 1. Negative 3 times negative 1 is positive 3. So the answers I've gotten is that x equals negative 1 and y equals 3. And this corresponds to the point negative 1, 3. But a good habit to get into is to always check your answers to see if they make sense, because it's really easy to make mistakes here. So we're going to check with both of our original equations. So doing a check with equation 1, I'm going to say that separate my left side and right side. So LS means left side. On my left side of my equation, I'm using these ones up here. I have 6x plus 2y. And on my right side, I have 0. So plugging in the answers I got for x and y, this gives me 6 times negative 1 plus 2 times 3. This gives me negative 6 plus 6, which is equal to 0. So my left side equals my right side. That's good. Let's check with equation 2. For equation 2, my left side is 7x plus 3y, and my right side is 2. Plugging in x and y, I have 7 times negative 1 plus 3 times 3. This gives me negative 7 plus 9, which is equal to positive 2. So again, my left side equals my right side, and that's good. I'm happy. So my checks worked out, and that means that these values for x and y are the solutions for the system of equations.